this video, the students will discuss about DT study on formation of functional nanofibers electrospun scaffold containing grapes for wooding applications. In this seminar, the students will discuss about the abstract of the study, what are the materials used, what are the methodology utilized, what are the research and discussions, and finally conclusions.
So first, I will be explaining about the abstract of this case study. First, electrospinning is an emerging tool and promising method to fabricate polymers and nanofibers. The aim of this work was to fabricate electrospun polyurethane mats reinforced with grapes for wound dressings. It was first confirmed that the fabricating novel composite scaffolds having better physiochemical properties suitable for wound dressing and applications. The next I will be explaining about wound dressings. Wound dressings plays an important role in managing certain types of open wounds. This includes traumatic, thermal and chronic wounds. The material utilized in making wound dressings were biological, synthetical and biosynthetics. And biological wound dressing, which is commonly used in clinics, are aloskin and pigskin, but they possess some drawbacks like limited supplies and high antigenicity, poor adhesiveness and risk of cross contaminations. Next I will be explaining about the electrospinning method. An ideal dressing must provide moist environment and allow gas exchange at wound interface to fight against microorganisms and also remove and for quick healing also. Wound dressing fabricates using electrospinning technique potentially offers many advantages over conventional methods. Electrospinning is a versatile, cost-effective technique which involves in applying voltage and polymer melt which drawn into nanofibers and collected at an end. The electrospun membrane helps in cell attachment and also proliferation, favoring the wound healing process. Next, material use will be explained by Peter.
Okay, I'm going to explain about the material use. The major materials used in our project is polyurethane and grapes. Polyurethane is one of the commonly used polymers in making dressing materials in the form of foams, membranes and films for the wound healing applications. Next, the grapes. In the word nanocomposite is derived using the additive called grapes. And fresh grape extract contains 70 to 80% of water and many organic and inorganic components like sugars and phenolic components, nitrogenous components, then aroma components and minerals. These are the which is extracted from the grapes. And few studies can be reported in the antioxidants and anti-cancers, anti-microbial and anti-inflammation activity. Okay. Then preparation of solutions. PU at 9% was prepared by dissolving 0.405 gram of PU in 4.5 ml. And subsequently grapes was 9% was used in fabricated. Then finally the solution of PU grape was prepared by mixing the PU and grapes homogeneous of 8:1 ratio, and PU composite solution nanofibers were obtained using the electrospinning technique which was explained right now. Then physiochemical characterizations. Scanning electron microscope and contact angle measurements and Fourier transform infrared spectroscopy analysis, then thermogravimetry analysis and atomic forces microscopy. Then some investigation will explain.
So I am going to discuss about the same investigation. It was found that the PU grapes nanofibers exhibited a decrease in fiber diameter compared to the pristine PU. The fiber diameter of the PU grapes membrane was observed to be 730 plus / 127 Newton meter, while the PU nanofibers showed a fiber diameter of 890 plus or - 117 nanometer. The smaller diameter will be favorable for fibroblast cell adhesion and proliferation. Next, the graph of the PU and the PU grapes is the intensity of the PU grapes is slightly higher than the PU. So the PU grapes will be greater than PU in wound healing.
Which clearly indicates the presence of grapes in PU. Okay. Next part.
So the contact angle is the water contact angle for crystal PU was found to be 100 plus or minus 1, indicating its hyperbolic nature, while the PU grapes nanofibers show a contact angle of 86 plus or minus 1, indicating its hyperbolic nature. The improved wettability will be favorable for fibroblast cells, adhesion and proliferation. Thermal stability. From the TGA curve, it was observed that the PU membrane showed an initial onset degradation, temperature at 276 degrees Celsius. And in the case of electrospun, PU grapes nanofibers, in the initial degradation temperature was increased to 289 degrees Celsius, indicating the increased thermal behavior of the electrospun nanocompositors. Surface toughness. The calculated surface toughness for the pure PU membrane was found to be 313 nanometer, while the electrospun PU grapes nanocomposites showed a surface toughness of 469 nanometer respectively. The incorporation of grapes improved the surface toughness of the PU membrane. The improved surface toughness will be sustainable for fibroblast cells, adhesion and proliferation.
Okay, and finally I will conclude my session. Our developed nanocomposites was based on the PU containing grapes. The addition of grapes showed enhanced physiochemical properties such as reduced fiber diameter, improved thermal stability, and improved wettability, and improved surface roughness, which can be suitable for the wound healing applications.